set, so enjoying the presentation. Okay, enable video playback. Okay, so hello everybody. This is Henry Cheney from University of L'Aquila, and I'm sharing this session. Let me just share with you one slide just to summarize the full presentation in this session. So we have four presentation. It's the session on autonomic system and self-adaptation that includes 3 papers from the software engineering in society track and 1 paper from the technical track. You can see the speaker highlighted in red in this slide. And the rule will be that there will be 5 minutes for each presentation. Since we have time, only 4 papers in this 60-minute session, the plan is to have 5 minutes question answer immediately after the talk, and then we leave 20 minutes at the end of the presentation. So the 4 authors and presenters are here, and they know that 30 seconds before the end of the time, I'll give them a sign to understand that the time is gonna finish. Yes. Say this extremely brief introduction, but I think useful. We are also using this ordering, which is the one on the Midspace, not the one on the ICSI website. So there is only one small change that they are not the same. So we are following this order for those of you that are attending the session. So at this point, I just stop sharing and I leave the space to Han Wang, presenting the first paper that has to do with their experience in engineering this COVID-19 dashboard and their experience in using this with a big number of users and a relevant number of developers and students who contributed to this project. Okay, so please.
Thank you. Hi, everyone. Thank you for coming to this session. I'm Han Wang, and I'd like to present our research, which is software engineers' response to public crisis, lessons learned from spontaneously building an informative COVID-19 dashboard. The researchers are from Monash University, University of Oulu, and Sarah 61. Here is an outline of our paper. Well, as we all know that the COVID-19 virus has spread quickly around the world, governments have taken actions such as lockdowns, border closures, work from home, etc., which has influenced people all over the world. Well, at first, we knew little about this virus. Therefore, people are urged to get the latest update and information about this virus. There are several ways to gain such information, for example, from the government daily release, from social media such as Facebook, Twitter, YouTube. People may also choose to watch TV news. However, they all have their shortages. Therefore, COVID-19 information dashboard are developed. In our scenario, we develop our own COVID-19-AU for Australian people. Here's the overview of the dashboard. It contains a homepage which illustrates the key data and visualizations. The information page contains the official instructions from government and trusted organizations, and the news page, which shows the live news from live news groups and the official Twitter account. The project characteristics. Well, we firstly published the website on March 2020. It is one of the first COVID-19 information dashboard in Australia. And we have over 200 volunteers from 12 different nations participate in this project. And most of them are undergraduate or graduate students from universities in Australia. We have received a large number of users and page views since we first released the website. And although most of the users are from Australia, we can also see some of them from other 184 different countries and areas around the world, as they may have friends or family members in Australia. Here's an overview of how we developed the websites, including team building, data collection, data visualization, requirement eliciting, web development, and testing and release. Well, with our first-hand experience and theories in software development, we summarized 9 lessons that are highly related to the pandemic. We categorized those lessons into 3 aspects: the developers, researchers, and instructors. And we believe that these lessons are helpful with people who work in the same areas. For example, lesson 1 for developers is be careful about sensitive data. We can see in the left-hand side with our old design, which we use pinpoint markers to represent confirmed cases in certain area. With such design, we received feedback from a user that one of the markers was actually pointed right on his form, which he's not happy with. We also received feedback like the pinpointer was pointed at a national park, which really confused the users that whether there are confirmed cases in the park in the lockdown. So we changed it to the updated version where we use different shades of red to represent the confirmed cases in certain area to avoid the ambiguity and misunderstanding. And there are also other lessons like use domain-specific terms, keep user count during the pandemic, and develop different features for different phases of the pandemic. During the development of the dashboard, we also collected user feedback and their overall usage activities through Google Analysis and come out with the 3 lessons that the researchers might be interested in, which are the people's information needs about cars, users' different interactions on mobile and desktop end, and also their interest in the interact with the map. Well, since most of the team members are university students, we also collected and summarized their experiences in participating in this project and listed several suggestions that we think is helpful for the SE instructors to teach software engineering principles and concepts during the pandemic through this project-based learning. Well, to summarize, this is a timely social good project for developing a COVID-19 dashboard within a limited time. This is also a case study which useful insights may be drawn on how to properly understand and design for human values as the 3 roles a software engineer can be. In the future, we hope to keep improving dashboard, and we're planning to develop a dashboard template for emergency disasters, for example, a earthquake, bushfire, or tsunami. And that's all I'd like to present today. Thank you for watching.
Okay, so thank you very much. So first of all, for those that just came, this session we will handle that we have 5 minutes presentation followed by 5 minutes question and answer, because we have only 4 papers, so we have some time. And we are following the order in the mid-space schedule. That is, there is this discrepancy with the one on the ICSI website, so we're using the one on mid-space. So I see here there is already a question. Your work mainly focuses on AU. What difference could there be for other countries? You may give some insights from your visited countries. So that's a question from Latif.
Right. I would say, first of all, thank you for the question. I would say in terms of the developers, or in terms of developers aspect, it would be not very different, because I guess the pandemic, the situation for the whole world would be very similar. And in terms of the researchers aspect, it can be different, because I guess like different people from different countries may have like developed different or interest in certain areas of the virus. For example, I would say probably, because I can see, well, comparing like our dashboard with like the other COVID-19 dashboard in other countries or areas, there's definitely a differences. For example, like the vaccine suppliers, or they're like some other dashboard also have a focus on, I would say, like the employment market, which probably employment market have been severely influenced in their country. Yeah, that's for the researchers' perspective. And for the instructors' perspective, I would say that should be very similar for different countries. And I guess that's the answer for this question.
Thank you.
Yeah, I have another question for you. What is specific in terms of software engineering challenges for this kind of application? I mean, you put this list of lessons learned. What I was wondering when following your long presentation and reading part of the paper, as what may characterize and differ when I'm engineering a different kind of application.
Well, I guess one of the biggest difference in this project will be timely needed, because it just like happened from nowhere, and we have no idea what other features that users need. So at first, we basically just developed it based on our own experience. We just ask whoever we can reach out. We like develop it from scratch to publish. It's only like finished in like 3 days or so. So once we build up the website, we realize there are a lot of things that we don't know that there's actually a need from the public. So we started to listen from our users and ask for them, reach out to them, like what are the features that they would like to know. And by like such approach that we keep delivering new features. And we have like adopted the agile programming for quickly changes on the requirements. We set the sprint to, we initially set the sprint to 1 week. In such way we could just quickly deliver wherever it's needed, urgent. And there's another thing I guess that's different from other practice would be the data sensitivity, because the numbers behind are like related to real lives. So we really need to be careful about this data. We need to make sure that no mistakes is taken. We have some bad lessons. I think we have mentioned that in the paper. So I guess that's also one difference.
Yeah, I'm also asking because we developed, I mean, I helped to develop an application when there was a big, how do you say, problem in India. So I supported an Indian team, and we wrote a paper, an IEEE software paper in the January-February issue. That's why I think that there are many parallel challenges, because we also had to use Agile, but a different way of Agile. And that paper is telling our experience on adapting a traditional Agile in the context of an emergency situation. That, as far as I understand, is very similar to your context.
I totally agree. So yeah, I'll go for it, have a look. We're also planning on like developing or come up with some principles that software engineers can follow when such emergency events is happening.
Yeah, exactly. Okay, so thank you very much.
Thank you.
And please stay in line for the the discussion that we will have at the end of the session. Let me give now a space to the second presentation given by Jose Miguel, and the paper is Lowering Barriers to Application Development with Cloud Native Domain-Specific Functions. So I know that, yes, you are here. Perfect. Please go ahead.
You hear me? Yeah. So yeah, thank you very much for introducing, and thank you very much for attending the session. My name is Jose Miguel Perez, and I'm going to present our paper with titled Lowering Barrier to Application Development with Cloud Native Domain-Specific Function. Creating and customizing application is a task that remains an expert task. Non-technical users, they are comfortable using content management like app, such social media, such as Facebook or Twitter, Webtoon or PrestaShop for creating shop. However, if they have to create an application, they are not comfortable using ADIs or frameworks or this kind of stuff. In order to allow non-technical user to generate application, one area that have made a lot of improvement is the use of domain-specific approaches and DSL. With this technique, the non-technical user, they are able to create an abstract behavioral models, and then using this as an input, using these techniques, they are allowed to generate code for the specific target platform that they want to get the application. However, this is not an easy task, and there is big changes, big challenges also here. For instance, they have to deal with multiple technological stack. There is heterogeneous clients. There is a lot of development tools. There is also different way of user interaction. It's not the same to generate an application for a voice-based platform such as Alexa, or for a screen-based such as a mobile phone. And still is the open question about how to provision and how to monitoring this app. In order to solve this problem, in our approach, the non-technical user, they also create an abstract behavioral model. However, we don't generate anything from this behavioral model. We execute it directly in the cloud. And then we propose something that we call a cloud coordination mechanism and a client coordination mechanism that allow us to decouple what is being executed in the cloud and the final clients. So thanks to this decouple, we are able to use generic clients. And this is because the kind of information that we interchange between the cloud and the clients is not graphical information about how the clients need to interact with the user. It's just the information that needs to be displayed to the user, the information that needs to be gathered from the user, some constraints and some values. But the responsibility of interact with the end user is the responsibility of the generic clients. Here we can see an example of one behavioral models. The boxes represent activities that come from a large library of activities that the non-technical user can use, and the arrow represent transitions. Our coordination mechanism keep executing these behavioral models always in the cloud up to the time that they determine that there is a needed user interaction. In this moment, it connects to the client cloud coordination mechanism, who is responsible of rendering and the interfaces to interact with the user, and also to collect the needed information from them. Once this information is collected, it's sending back to the cloud coordination mechanism, who continue the execution. In order to evaluate our approach, we have created a prototype, and we have used we did a user study also. With our prototype, we have implemented a well-known application, and we have compared this implementation with other existing for both backend and frontend. As you can see here, in general, we need less line of code for implement the same functionality. And if we introduce a chain in this application, we can see that in our case for backend, we needed to change just a few lines of code. And in the case of the frontend, because our clients are generic, we don't need to modify any line of code for introducing this chain. About the user study, you can see some quotes here of the participant, of course. And in general, we can say that this approach seems to help in this way of letting them to create an application for any platform. So that concludes my presentation. Thank you very much. Yeah, if you have any question, I'm happy to. Thank you.
Okay, so thank you very much. So let's see if there is any question, because otherwise I have one. So you said at the end that you can, in this way, realize any type of application, or there are some application domains that are, let's say, more suitable for your approach, and other type of application that are more difficult to implement through your approach?
I mean, I would like to say that any kind of application is possible to model, but it's true that there is some applications that are easier. For instance, a game is out of the scope of this, but because it requires many graphical stuff and this kind of stuff. But I mean, common application, I think, is possible, but because also, I mean, our generic clients, something that I didn't mention because I didn't have time, they can be also customized. The generic clients is also prepared for for certain things, if you want to customize to put your look and feel or to behave, to make they behave a bit different. Of course, this is something that needs to be done by people that have more knowledge if they want to customize the app. But the good thing is that once this generic client is customized, it also adapt to any behavior that is being executed in the cloud. So the not technical user can still do changes and modify the behavior or introduce new behavior in these clients without needing to touch it. So yeah, I think that we, of course, there is some kind of application that are out of the scope, but in general, I think this is possible to.
So do you think that this approach can be included in the low-code, initiatives that are becoming more and more popular?
Yeah, definitely. Low code or even no code, because it depends of the granularity of the library that are able to use for creating these flows. We did some experiment where not even a line of code is needed to generate an app and to model this behavior.
Okay. So do you had a chance to compare also with other low-code platforms?
Yeah.
Okay, well, that's interesting. So let us see if there is any other comment or question related to your presentation from the audience. Okay, it seems that there is not at this time. Thank you very much. And please stay online for the final part with some discussion. Thank you. So let me invite now the third presentation from Hao Xu on automated assertion generation via information retrieval and its integration with deep learning. Yes.
Okay. Hello, everyone. I'm Hao from Peking University. The title of our work is Automated Assertion Generation via Information Retrieval and its integration with deep learning. And this work was done in collaboration with Peking University, Purdue University, and the Huawei company. I will first introduce the background of assertion. Assertion is used to validate the correctness of methods. Here is an example of a test method with an assertion. The place cycled by the red box is the assertion, which is used to judge whether the implementation of the getting method is correct. In recent years, based on other already written unit tests, Atlas takes the test method without any assertion, along with its focal method to output an assertion. The output of Atlas is an assertion. The input of Atlas contains focal method and test method. The focal method refers to the method under test. There are two major limitations of Atlas. First, assertions generated by Atlas are not explainable due to the unexplainable nature of deep learning. Second, the effectiveness of Atlas is still poor. To address these limitations, we propose our approach. Our approach includes an IR-based approach and an integration approach. The IR-based approach contains two techniques: IR-based assertion generation, in short as RAR, and retrieval assertion adaptation, in short as adapt. Here are the IR and the example IR to generate an assertion for the input focal plus test method. IR compares it with each focal plus test method in the training set. Find the most similar one. And return its corresponding assertion. Next, I introduce the IR adapt technique. I see the session track is autonomic systems and self-adaptation. I think this slide is the most suitable slide in our work for this session topic. In this slide, we propose an automated adaptation technique, Adapt. Adapt first decides whether the assertion should be modified. Adapt considers an assertion necessary for adaptation if it contains at least one token absent from the input focal protest method. Then Adapt decides which token should be modified. Adapt contains a token that is not is absent from the input focal protest as a candidate token for modification. Finally, Adapt decides what value a candidate token should be replaced with. For this step, we design two replacement strategies to decide the replacement value. One is based on heuristic, and the other one is based on neural networks. Next, I introduce the integration approach. We propose an integration approach based on a capability inference model, which calculates the capability between the retrieved assertion and the current focal protest method. Then I introduce the evaluation. We conduct experiments to answer the following research question. Table 2 shows the RR-AR technique substantially outperforms the compared DR-based approach Atlas on both two datasets. And the table 4 shows that IRAR could consistently outperform Atlas on all the assertion types. Table 5 shows the similarity coefficients have little impact on the effectiveness of RRAR. Then I introduce RQ2. Column 3 and column 4 in table 2 show that both adaptation techniques can substantially improve IR, AR, and RE-adapt NN can achieve higher improvement than RE-adapt H. Then I introduce RQ3. The last column in table 2 shows that the integration approach consistently outperforms the DR-based approach and the RR-based approaches. Finally, I conclude our work. We have made the first attempt to leverage information retrieval assertion, information retrieval in assertion generation, and propose an R-based approach, including the technical RAR and the technical adapt. We have also proposed an integration approach. Experimental results demonstrate the effectiveness of our method, our approach. That's all. Thanks.
Okay, so thank you very much for those that just came into the session. Since we have only 4 papers, we are making 5 minutes presentation and 5 minutes of questions, and then 20 minutes of discussion at the end. So if any of you has any question, please go ahead, and we will share it with Hao.
Can I ask a question? So I'm curious, because you compared your tool with Atlas, and I assume like most of the test cases are written in Java. So my question is, would they have like a different performance on other programming languages?
So I just dropped the line. Can you repeat it?
Oh yeah. Cool. So I can see that your test cases are mostly written in Java, but I had to look at your implementation. I'm assuming that your approach can also working on other programming languages.
Yes.
For example,
yes,
like Python, C++.
Yes,
like,
I think Yes, I think our approach can be expanded to other language because our approach based on information retrieval and
yeah.
okay.
To follow that question, you compared your performance with Atlas, which is like a state-of-art deep learning approach. Speaking of a general perspective, because we all know that currently code completion tools like GitHub Copilot or some other code completion technique is also trying to like achieve the similar goals. I'm not sure if you've like did some experiments on that.
We don't do any other experiments such as compared with Copilot and other program generation tools. We only compared our approach with the state-of-art approach with for other generation.
Right. Cool. Thank you.
Maybe we can try it in the future work.
Yeah, I'm just asking out of curiosity because I can see that your tool is specifically designed for assertion completion.
Yes.
Yeah, I'm just like curious to see whether like other like in a general term, code completion compared with assertion completion, how they perform differently.
Thank you.
Yeah, I'm curious. Thank you.
And I see that you, Mohammed, there's also another question if you want to just tell a voice.
Sure. From your paper, I can see that you compare result with blue score and accuracy. So you are currently generating unit test code. So I'm thinking, is there to check another metrics like code blue, actually check how accurate you generate the code, and you can check exact match for that. Is there any plan to do that?
You mean we need to compare with code glue?
Yeah, code blue just another blue type matrix, but it actually dedicated for code generation.
Sorry, I didn't hear. I not hear very clear.
Okay, I'm thinking about just use compare your approach with the state-of-art approach based on the accuracy and blue score. So, but you are generating code unit code. So I'm suggesting you can check your score based on code blue score or exact match. Just suggestion.
Okay, I see. You mean I need need to use the code glue matrix to evaluate our approach. Is this?
Yeah, I think you can just check the score and report in your paper. I think this is suggestion. I think you compare your result with previous to the other with accuracy and previous score, but actually, yeah, currently you are generating unit code, so you may check this type of score. I think just a suggestion. I think not a question.
Okay, thank you.
Okay, so let's see if there is any other question. No, I think that we can move on. Thank you very much for the presentation. We can move on with the fourth paper in this session, presented by Paulo Enrique. It's about DressML. Yes.
Okay.
So this for those that just yes, for those that just arrived this session and only 4 papers. So this is the 4th papers. So after the paper presentation, we will have another more or less 20 minutes of question and answers. So if any of you that just came and is interested to, make questions or share information, please stay with us and we will have this time at the end of the presentation. So please go ahead.
Okay. Thank you very much for everybody coming. My name is Paulo Henrique Maia. I'm from the State University of Ceará in Brazil, and I'm going to present the paper entitled DressML, a domain-specific language for modeling exceptional scenarios and self-adaptive behaviors for drone-based applications. So currently, drones have been used in several civil applications, although they have initially created for military purpose. So we can see drones being used for building inspection, search and rescue, and also for delivery and monitoring of goods. Drones can be operated either manually, in which a human can pilot the drone, or automatically, in which the drone can fly autonomously, following a predefined path. However, that some uncertainties may happen during flight time that are very difficult to predict at design time. And those uncertainties may generate exceptional situations that may impact the drone-based application. So to deal with those exceptional situations, we can either create drones, which is a very expensive, costly, non-reusable alternative, so it might be impractical, or enhance drones with self-adaptive capabilities. In this case, the drone can monitor its internal state and the environment variables and can decide to change the behavior according to some parameters. So there are some work that have proposed different approaches for dealing with self-adaptive drones. Some of them deal with the self-adaptation of the drone itself, including quality requirements and privacy, or architectural or behavioral adaptations. So all of them need technical skill from the developer or the user who is developing the application. On the other hand, we have we can specify exceptional scenarios for drones, but even if we are using generic modeling notation or a drone-based modeling notation, we have from the state of the art, from the literature now, very restricted scenarios that can be modeled. So to tackle that problem, we are proposing the DressML modeling language, which is a domain-specific language that allows users to specify both exceptional scenarios and self-adaptive behavior for drone-based applications. And to do that, it relies on the behavior-driven development concepts, the well-known given when then structure to model the exceptional scenarios, and aspect-oriented programming concepts, especially point cuts and advice to model the self-adaptive behavior. We can also create some model-to-text engines that receive inputs, the DressML specification, and outputs code for specific target drone simulators or real drone platforms. So in our domain analysis, we analyzed different aspects from the drone, its internal states, some aspects related to the flight operation, the mission itself, and others regarding the drone sensors and actuators. So in our approach, our abstract synthesis of our modeling language, we have an exceptional scenario that has a name and is divided in three main parts: a given, in which we have a conditional express to express the word, the state of the word, the when, in which we express an event that must happen at that time, and a then clause in which we specify the adaptive behavior. So this is an example of an exceptional scenario modeled using the DressML. So initially have a title or a name for the exceptional scenario. This one is keep flying, which means that the drone should keep flying when there is a situation in which the drone is close to the destination and the wind is favorable for keep the drone flying. Then when the drone is supposed to do a safe landing procedure, then the drone, instead of doing that procedure, it has to go to the destination following the specified commands. We evaluated our approach using proof of concept, in which we modeled an application to monitor forest to search for fire spots. We used a Dragonfly drone simulator to model, to create the scenario and to validate our model to text transformation. And we had shown that our approach is valid and may be helpful to specify exceptional scenarios for other drone-based applications. But we know that there are still much work to do, and we are currently investigating some of those steps. And now I'm open for questions. Thank you very much for your attention.
So thank you very much. So let's see if there is any question coming from the audience. Meanwhile, let me ask you this. When I saw your model that you're using, the given, when, then template, I was wondering now, just looking again at the presentation, how much it differs from even condition action. Because it looks to me, I mean, at the first look, at least, okay, I'm not saying going to the detail, but it came to my mind the even condition action. I'm wondering how much your template is different from an even condition action type of application.
Okay, it's not that much different, but I think the main benefit for the user to use our approach is that we are using a very well-known structures from the requirement engineering world. So I think that it will be easier for the user to think and model this exceptional scenarios using a technique that probably he's already know. In addition to that, we think that there to specify the behavior, the adaptive behavior, the AOP can be a good alternative. So we can use some of the concepts that come with the language, like the advice one, in which we can specify if the adaptive behavior should to take place around the predefined one or before or after the one. So our main contribution is to give a language in which the user can model all of them and in a higher level of abstraction. So he or she will not be able, or sorry, will not be necessary to know technical details about the programming language and can be more focused on the domain that it's being modeled and the scenarios that are being tackled at that time.
Mm-hmm. Let me see again. I don't want to get into another question if there is people with a question in mind. Okay, then I have another question. How much it compares with state-of-the-art research in self-adaptation? I mean, there is quite a long time community working on methods for self-adaptation, and different communities, even here collocated with ICSI, related to self-adaptation. I would like to know a little bit more about how it relates, your approach relates with the other self-adaptation approaches.
Okay. In fact, this approach is nearly a continuation of a previous work that we have in the self-adaptive community, in which we proposed a cautious adaptation approach that we used as an example, a drone. So that example that I showed here for the keep flying exceptional scenario, it comes from that work that was published in the AIC 2019. But we saw that at that time we are using a very low level approach for not specifying, but in fact for programming the self-adaptive behavior. And in this paper, we are trying to make the abstraction higher in terms of changing the user of the approach that in the first work was the programmer, and now we are offering for the modeler or for the requirement analyst a more generic modeling language that he can try to model those aspects, but not necessarily being aware of technical details of how they will be implemented in some specific language or in some drone platform. So for instance, we used drone simulator and we created a model to text transformation engine that receives XML specification, and then it outputs code for this specific drone simulator. But we want to try that with another drone simulators, or even real drone platform that would be our main target, that is showing that our proposed approach could be very useful for real users and in real drones. That's something that we want to do in future work.
Okay, so thank you. Let me call back also the authors from the previous 3 presentations, and we have another 15 minutes, and I'll share 1 second again the list of papers that have been presented, especially for those that maybe arrived later. So those are the 4 papers that are part of this session. Let me check first of all if there is any question, any overall question from the audience.
I have
Paulo,
a
would
question.
you stop sharing your?
Sorry?
Possible? Okay, sorry.
Thank you.
Okay, thank you. So yeah, there was one question, please.
Yes, I have a question to Jose. Jose, congratulations on your work. I think it's in some way our work has some similarities because we are dealing with DSLs and also trying to make the abstraction higher. I would like to know more about how the user that models the behavior models knows about the output of your work. So do they have to know the specific cloud platform or the specific IoT device? And I would like to know a little bit more in details how it works.
Let's see. What the end user models is just this behavioral model that we saw there, where they don't deal with any let's say with any end user interaction. We just say, okay, and in this particular moment, I need to show this to the user. I need to get this feedback. For instance, imagine that there is an application that lists a set of articles and you want to select one for get detail. In a specific moment, they say to the user, okay, you have to show this list of articles, and then as output, I want to receive from the user the selected one, or if he want to paginate, then the next to receive more. Okay, this is for this what we have in our prototype. While they are developing, let's say, these behavioral models, they are allowed also to execute and to see in a monitoring tab what is the inputs or the outputs that is being generated. And then for when this goes to the target application, what we have is generic clients that they have the code to adapt to the user. For instance, imagine that is a client which is a voice-based platform, an Alexa, and receives this output, which is you have to tell the user the list of articles. So what's happening when Alexa receives this input is that starts speaking something like, this is the title of the article 1, article 2, and then please give me the article you want more detail. So, and this is the responsibility of the platform to generate this user interaction. But with exactly the same communication, if the target application is, for instance, a screen-based, what the mobile or what the screen-based platform target is, it have the code to render this page with all the article for the people for the user to click. So how it works, the communication is always generic and is the responsible of the clients to interact with the user. I don't know if this solves your question. Actually, sorry, you was on mute. You want to say something?
No, just thank you.
Okay. Sorry. I also have in mind also a question for you. So I wanted to know also when you have this DSL, when the user model this DSL, what do you do with this DSL? Do you generate code for that executed on the drone, or do you put like in a brain that is sending the command to the drone from remote?
Okay, good question. Our DSL only models the exceptional scenarios and the adaptive abstraction. So if you want to create a code for a specific drone platform, you need to implement a model-to-text transformation engine. So like we did in the paper for a specific drone simulator. We also know that as we are using a more abstract way of describing some drone elements, there's also the user has to know how to match our concepts to the specific drone platform. So another thing that we are also aware is that we know that maybe not all drone simulators and even real drone platforms are ready for self-adaptive behaviors. So this is something that the user also has to be careful when choosing the target platform to generate this specific code. But yes, he or she can do that from from the model that he created. We provided a model environment that is based on the JetBrains platform, but for creating specific drone applications, so it's up to the developer. Thank you.
So,
Okay, thank you. So please.
Yeah, I'm not very familiar with the concept or the area that you are doing, but just based on the question that Jose just asked, I'm wondering, is there any limitations, like say on the hardware of the drone, that may somehow influence the model they design?
Sorry, could you say it again, please?
I mean, is it basically you design a platform, a model that can be applied to the drones? I'm wondering, like, are there like some like hardware limitations on the drones, like different types of drones that like somehow that the model cannot work on?
Yes, because we try to gather most information as much information as possible from the drone world, but some drones may have not all the concepts and abstractions that we are proposing in the language. So hardware is a limitation, and in fact, we should have pointed it out in the paper, because not all drones may be eligible for running the scenarios that the user specified using our modeling language. Yes.
Thank you.
Okay.
Thank you.
Thank you. So I don't know if Haokshu is still connected, because I know that potentially yet to leave, but I still see his icon here. Because my question, in case is still with us connected, it's about how if the testing approach that it was presenting may help in on what you have been presenting in the other papers. But let's see if he can answer. He told us at the beginning that he has some troubles with the timeline and it's very late, so maybe it's not. He cannot respond anymore. No. So I don't know if there is any other co-author of that paper here that could provide any feedback on this question. Probably no. Okay. So what I see summarizing, the 4 papers, again, they are quite different, but I think that we have been good to find some intersection between them that were not immediately visible, I would say. So the first paper is about this experience in creating this dashboard. This dashboard for COVID-19 and all the users and the difficulties, especially in an emergency situation. Second paper was about these behavioral models that can be used for, let's say, low code or no code generation in a sense. The third paper was about automated assertion generation for testing, and the fourth paper was about this DSL for drones. What I was, checking as similarities or links as something that you already discussed in a sense. So how, for example, the paper presented by Jose Miguel could be interact or intersect with the paper on DSL for drones that we discussed. I was also reasoning about, how the same approach could manage the COVID-19, but in that case, my understanding that it's full of graphics. So I don't know, and they're full of data. So I don't know if for that kind of application that is really data-centric and let's say UI-centric, my understanding is that the behavioral model, it's not really helping very much. I don't know if I'm wrong or I'm saying it correct.
Actually, I mean, it's true that for this kind of application, the customize it. But as far as, I mean, once you have this customized, yeah, you can also create this kind of application. Actually, we are now also we are working now also on to provide visualization for data set for AI pipelines. So it's kind of data-centric application. So yeah, I think it's also possible. Of course, the clients, the generic client probably not for sure. The generic one will not end up with this look and feel, but once it is customized, it's possible to use.
Okay, so thank you very much. I don't know if there is any other comment. Let me just remind the audience that videos are recorded and available. Some of the videos of the long presentation are available on the ICSI website for this session. And some other information is also available on Meetspace, like abstract or brief summary of the paper. So for those of you that want to go back and know more about the papers, I think that the easy, fast way is really to go through this material, and then we also have the full paper that we wish we have the time to read, especially if the papers are related to our research. Said this, I think it's time to close. Thank you very much. So I hope all of you the best fortune for your research, and hope to see you again the next ICSI, hopefully all in person, or for the in-person version of ICSI in a few weeks from now. So thank you very much.
Thank you.
Thank you. Bye-bye.